In the 1980s, computers like the BBC Micro invited students to tinker. They booted straight to a command line, forcing users to type code just to make them run, which naturally encouraged kids to learn programming. By 2008, that culture had largely disappeared. Modern consumer tech, particularly the new smartphone market, favored polished, sealed devices. These closed systems hid the underlying logic of computer science away from the user. The impact of this shift reached the highest levels of academia. At the University of Cambridge, the computer laboratory noticed a steep drop in both the total number of applicants and their baseline programming skills. Computer scientist Eben Upton and his colleagues recognized a practical barrier. A modern family PC was an expensive investment, and parents actively discouraged children from experimenting with its software out of fear they might accidentally break it. To solve this, Upton and the newly formed Raspberry Pi Foundation set a highly specific hardware target: build a fully functional open-board computer the size of a credit card, with a target price of exactly $35. At that cost, a computer becomes disposable in the best possible way. By reducing the financial risk to the price of a standard textbook, a student could crash the system, short out a component, and simply try again without ruining a major household asset. When the commercial Model B launched in February 2012, massive global demand instantly knocked the distributor websites offline. The immense interest was driven by the board's exposed anatomy. Instead of hiding the components inside a sleek case, the raw circuit board invited users to inspect exactly how the hardware fit together. Looking at this diagram, the defining feature is the block of pins highlighted here, the GPIO. It forms a bridge between software and the physical world. A Python script converts into electrical signals traveling through these pins to operate LEDs, read sensors, or spin motors. Standard PCs typically limit your output to pixels on a screen or sound through a speaker. To manipulate physical objects, you usually need expensive, specialized industrial adapters. By integrating those physical connections directly onto the main board, the Raspberry Pi acts as a digital brain capable of flexing mechanical muscles. Over time, the design branched in two directions. To lower the barrier of entry even further, the foundation developed the Pi Zero, shrinking the form factor and the price tag down to just $5, and later introduced the Pico microcontroller, running on custom in-house silicon for $4. This chart compares the processing power of the original Model B against the recent Raspberry Pi 5. We see a steep upward climb in both clock speed and memory, with modern iterations supporting up to 16 gigabytes of RAM and driving dual 4K displays. That raw power opened up an entirely different market. The foundation stripped away the standard ports to create compute modules, compact, high-performance boards designed to plug directly into customized carrier boards for industrial use. Commercial engineering requires long-term stability, so Raspberry Pi implemented a policy guaranteeing that their core models remain in active production for at least 10 years. This commitment to hardware availability allowed a tool originally designed to teach middle schoolers how to code to scale into a reliable component driving factory floors and commercial automation across the globe. The sheer volume and low cost of these boards made them critical during global supply chain crises. During the COVID-19 pandemic, medical teams in Colombia relied on the accessible Raspberry Pi Zero to serve as the computing core for life-saving ventilators. Today, the platform handles advanced edge computing. Using an add-on board like the AI Hat Plus, which features a dedicated neural processing unit, developers can run complex machine learning and computer vision tasks entirely locally without relying on cloud servers. In fact, the hardware has even survived the intense physical strain of a rocket launch into Earth orbit. Aboard the International Space Station, specially augmented boards known as AstroPis monitor the cabin environment using arrays of pressure, humidity, and radiation sensors. As part of this program, British astronaut Tim Peake executed experimental Python scripts on these orbital devices, running code that had been written entirely by primary and secondary school students back on Earth. By 2015, the Raspberry Pi officially surpassed the iconic 1980s ZX Spectrum to become the best-selling British computer in history, and it has since pushed past 68 million units sold. The foundation succeeded in reviving the hands-on culture of early microcomputers by proving a simple point. The most powerful attribute a piece of technology can possess isn't its raw processing speed. It is how easily people can afford to get their hands on it.